Hi everyone, today we are going to see how to recover an old PC power supply and ATX power supply to make an inexpensive bench power supply, with fixed voltages of 5 volts and 12 volts. The first thing to do is to check its operation, and to get this power supply to start up, we need to jumper 2 pins. The first is pin 14, which is the power switch. The second pin to connect it to is a ground. In practice, by grounding the power switch pin, the power supply starts up. Next we check the presence of the 2 outputs we will need, i.e. that of 12 volts, which corresponds to the yellow wire, and then that of 5 volts, which is on the red wire. So by putting the multimeter in DC volts, connecting the black lead to ground and the red lead to yellow, respectively, to read the 12 volt DC and the red lead to read the 5 volt DC. We actually verify the operation and stability of the outputs, in this case at no load. Well, now that the power supply has passed the first few checks, we can proceed to open its casing. At this point, I want to bring a little attention to the components, especially those that work at high voltage, such as the 2 capacitors that we saw a moment ago. So since we have just powered it up, I recommend that we do not touch either the leads of the components, or the metal parts, so without being insulated, because some quite dangerous voltages could also be present. At this point, we can proceed with removing the 4 screws at the corners of the board, so that it can be separated from its container. At this stage, I checked for the presence of voltage at the ends of the 2 200 volt capacitors, which we saw a moment ago. Unfortunately, you can see the value on the multimeter in the pictures, but I verified that there was no longer any voltage, probably an additional circuit, discharging the capacitors, designed to avoid these dangerous situations. Now that the soldering iron has warmed up, we can proceed with the desoldering of all the superfluous cables. I remind you that those we will keep will be the black, yellow, red and grey cables that we will need to enable the power supply to be switched on. Everything else will be removed. Now that we have also desoldered the last cable, we can start cutting away all the connectors, clamps and separating the cables by color. It is important to balance the ground cables between the two outputs in proportion to the currents that each output supplies, so a division must be made on the basis of the current indicated on the power supply's rating plate. We now connect the two cables, the grey one which is the power switch, the power supply enable, and the ground which enables the power supply to start up. We now clean the board of any tin whiskers, short circuits that may have been created during the desoldering of superfluous cables, and then we reassemble the board in its box. At this point, I am insulating, to protect, the cable sheaths from the edge of the chassis, and I also run the cables all together through a rubber cable grommet, which is then clamped onto the metal edge of the box. Instead, I now proceed with sealing in the box and attaching the terminal block, using adhesive bases and clamps, to the top of the box. The work that remains to be done now is all downhill, as we have to cut all the cables to size and split the 5V on 2 terminals, because the 5V is the one carrying the most current and the 12V in the remaining one, leaving 3 terminals for the respective grounds of the 3 outputs, 2 5V and 1 12V. To protect the cables that I collect, to block terminal blocks, I use, and I find myself crimp bushings, to prevent the terminal block screw from breaking the strands and over time reducing the cable cross-section, the total cross-section. Now that we have fixed all the output cables, we can proceed to labeling. In this case, I did this in a very simple way, using paper tape and marking the values of the output voltages and polarity with a felt tip pen. Obviously, this is a job done on the cheap, so thinking more about minimizing costs, given that we're salvaging an old power supply anyway, and that perhaps not everyone is willing to spend money on superfluous frills to make a power supply that more or less does the same thing, but which shows you a voltage value that is written on the label. We have finally arrived at the final test. So with the DC voltage multimeter, we are going to check the values of the output voltages from the terminal blocks, in this case at no load, but in one of the next videos, I want to put them under load and see if the voltage remains constant and the ripple remains at acceptable values. At this point, the job is done. It even came out pretty neat, and for very little money. The current that it can supply at the output is also quite high. On the 5 volt we have 30 amps, while on the 12 volt we have 10. The protections on the cables and on the sheaths such as the sheath and the crimping bushings have been inserted. If you want to add protection on the current output, you can also fit fuses, and then the project is finished. I hope with this video, that I have managed to make a few people aware of the subject of recovering hardware that still works. Often in PCs that are scrapped, the power supplies are those items that can still work for a long time, so when an electronic item is still functional and reusable, think twice before throwing it in the WEE and creating environmentally harmful waste. Well, at this point I'd say we're done, and if you liked the video, remember to leave me a like and subscribe to my channel. But if you want to receive automatic alerts every time I upload a video, also click on the little bell. I'll say goodbye now and see you at the next one. Bye and have fun.